friends, welcome back to Relief Tutorial. Today we are going to discuss a new chapter, number system. So first of all, we will discuss numbers. See, in lower standard we have discussed about the number line. You know this number line, clear or not? Number line, see here I will write 0, 1, 2, 3, dash, 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 4, minus 1, minus 2, minus 3, these are number line. But first of all, we will talk about natural numbers. See here, natural numbers. Natural numbers is denoted by n. So what are natural numbers? You know that generally in mathematics we use these numbers in order to count objects, or in order to label and in order to measure. We use all these numbers. So what are natural numbers? So numbers which are used for counting. Numbers used for counting. Numbers used for counting. Counting, that is 1, 2, 3, dash, 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 dash are called natural numbers. Are called natural numbers. So numbers which are used for counting are called natural numbers. Smallest natural number is 1. See, natural number we can say it is denoted by n, and if you want to write in the form of a set 1, 2, 3, 4, 5, 6, dot, 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 dot. All these are natural numbers. So smallest natural number is 1. But we cannot find the largest natural number, as successor of every natural number is again a natural number. See, successor of 5 is 6, so it is a natural number. Successor of 6 is 7, so again it is natural. So smallest natural number is 1, we cannot find the largest natural number. Then comes whole number. See, whole numbers. Whole number is denoted by depth. So natural number together with 0. Natural numbers together with 0. Together with 0 forms the whole number. So natural number, if you add 0 to the natural number, we get whole number. So whole number is, we can say 0, 1, 2, 3, 4, 5, dot, 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 dot. So these are whole numbers. So 0 is the smallest whole number. And here also we cannot count the largest whole number. Clear? So these are whole numbers. Now comes integers. Integers. So what are integers? So the collection of all whole numbers. The collection of all whole numbers. See, integer if I say. So collection of all whole numbers 0, 1, 2, 3, 4, 5. This collection of all whole numbers and negative natural numbers. These are whole numbers. So collection of whole numbers and negative natural numbers. That is, negative natural number is minus 1, minus 2, minus 3, dot, 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 dot. So these are called integers. See, these integers I have represented on a number lines. So what are integers? So collection of whole numbers and negative natural numbers are called integers. So collection of whole numbers and negative natural numbers. Are called integers. See, it is denoted by Z. Actually, you know that Z comes from German word Zellen. It comes from German word Zellen. Clear? Zellen means to count. And the Z-A-H-L, Zal, is called numbers. Zal means number, Zellen means to count. So we can say all whole numbers and negative natural numbers are called integer. See, 0. 0 is neither positive nor negative. Clear? So we can say that positive natural number, negative natural number and 0 is called integer. So now from this we can say all natural numbers, see 1, 2, 3, 4, 5, 6, 7, all natural numbers are whole numbers. Can we say that all whole numbers are natural numbers? No. 0 is a whole number, but 0 is not natural number. So we can say all whole numbers are not a natural number. Can we say all whole numbers are integer? Yes. All whole numbers are integer. All natural numbers are also integer. But all integers are not whole number. Why? Because minus 3 is an integer, but it is not a whole number. Clear? So these are integers. Now comes rational numbers. Now comes rational numbers. See, what are rational numbers? So rational numbers. Rational numbers. Rational number. It is denoted by Q. What are rational numbers? So the numbers which can be expressed, the numbers which can be expressed in the form P by Q, where PQ belongs to Z and Q is not equal to 0. This denominator should not be equal to 0, are known as rational number. Have you got it, friends? Very important. The same chapter you are going to learn even in 10th standard also. So the numbers which can be expressed in the form P by Q, where P and Q both are integers and Q denominator is not equal to 0, are called rational number. And it is denoted by word Q. So we denote this rational number by Q. Here rationals comes from the word ratio. Rational comes from the word ratio. And Q comes from the word quotient. Quotient. There is a quotient. Quotient means here you know division is called quotient. So it is denoted by Q. So Q is nothing but all those numbers P by Q. Means the number which can be expressed in the P by Q, P comma Q belongs to Z and Q is not equal to 0 are called rational numbers. Say example, we can say 0 is a rational number. Why? Because it can be written in the form 0 by 1. Okay, minus 1 by 2. See, P belongs to Z. Q is also Z. 2 is also integer. 2 by 3, we can say 7 by 3, 5 by 50. All these are rational numbers. So we can say that all natural numbers are also rational numbers. See, if we draw a number line here, 0, 1, 2, 3, minus 1, minus 2, minus 3. See, this 1, 2, 3 are natural numbers. 0, 1, 2, 3 are whole numbers. These all are integers. And what are rational numbers? See, if I say here, this point, 0, this is called half. 0 and 1, in between 0 and 1 we have half, 1 by 2. So that is what it is a rational number. Why? Because it is expressed in the form P by Q and Q is not equal to 0. So there are how many rational numbers between 0 and 1? So there are infinite rational numbers between 0 and 1. Clear? So all these points which are lying in between all these integers are rational numbers and irrational numbers. So 1 by 2 is rational number, we can say. 1 by 3, here it comes 0.33333. So this is 1 by 3. Clear? So we can say this all gaps can be filled. So rational number exhibits the gaps. It fills the gaps. So all these numbers lying between 0 and 1, there are such infinite numbers and some of those numbers are rational numbers. Clear? Now, we will discuss few notes. We can say every natural number is a whole number. Yes, every natural number is a whole number. Every whole number is a natural number except 0. So many such points are there I will discuss here. 0 is a whole number but not a natural number. Every natural number is an integer. Every natural number is an integer. Every whole number is an integer. 0 is neither negative nor a positive integer. I told you this. 0 is neither negative nor positive. 0 is a rational number. 0 is a rational number. Why? Because the 0 can be written as 0 by 1. Every natural numbers are rational number. Why? Because 1, 2, 3, 4, this can be written as 1 by 1, 2 can be written as 2 by 1, 3 can be written as 3 by 1, 4 can be written as 4 by 1, 0 can be written as 0 by 1, minus 1 can be written as minus 1 by 1. So all these integers are rational number. Why? Because all integer m are rational number. Why? Because it can be written in the form m by 1. Clear? So I can say there are infinitely many rational numbers between any two given rational number. See, 0 is a rational number, 1 is a rational number. In between 0 and 1 there are infinitely many rational numbers. Again we will discuss in detail, but at particular moment you should know what are rational numbers. So the numbers which can be expressed in the form p by q, where p and q belongs to z and q is not equal to 0, are known as rational number. And generally you know this p and q are primes, co-primes. Prime number means which has only two factor 1 and itself. Okay, so that we will discuss now. Before discussing that, we will discuss equivalent rational number. Equivalent rational number. Equivalent rational numbers. What do you mean by this equivalent rational number? See, this 1 by 2 can be written as 2 by 4. That can be written as 3 by 6. That can be written as 4 by 8. That can be written as 5 by 10. That can be written as 10 by 20. See, 2 by 4 means 1 by 2. This 1 that is 2 that. 3 by 6 means 1 by 2. 4 by 8 means 1 by 2. So all these are equivalent rational number. All these are equal to 1 by 2. So they are in reduced form. You cannot divide this further. Here you can divide them further. This also can be divided by further. This can be also further divided. This can also be further divided. 5 ones are and 10 twos are. So all these are called equivalent rational number of 1 by 2. These are C co-primes. Okay. See, 3 by 5 can also be written as 6 by 10. Both are equivalent rational number. 2 3s are, 2 5s are. But here you see this is not a prime, this is not a prime. It can be divided further. But 3 by 5, 3 numerator, P is a prime, Q is also a prime. So P and Q are co-prime. P and Q are co-prime. So it will be in reduced form. So now you know what do you mean by equivalent rational number. So we can say the number which can be expressed in the form P by Q, where P and Q belongs to Z, Q is not equal to 0, and P and Q are co-prime. P and Q are co-prime. Means which cannot be divided further. So this is ephemeral knowledge of rational number. Again we will go in detail, but when we discuss decimal expansion. But these are the rational number. Now we are going to find method to find the rational numbers between two rational numbers. See, this method is very important. Now first, when one rational number is determined. 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 See, I can say, if I say let x and y be two numbers, such that y is greater than x. X and y are two number, y is bigger number, x is smaller number. Okay. Then x plus y, arithmetic mean of these two numbers. If you add these two numbers and divide by 2, this is called arithmetic mean of two number x and y, is a rational number. Lying between x and y. So if you want to find any one rational number lying between two numbers, you can find by this method. See, for example, we can find a rational number between 3 and 4. Rational number, you have to find a rational number between 3 and 4. So you know rational number between 3 and 4 is 3.5. So how you will find here? So here see, we can say okay, 4 is greater than 3. So let x is equals to 3. Smaller you have to consider x. and bigger you have to consider y. Y is equals to 4. Clear? The rational number between 3 and 4 is, so rational number between 3 and 4 is, I told you, x plus y upon 2. X plus y upon 2 is 3 plus 4 upon 2. So that is equals to 7 upon 2. So 7 upon 2, P by Q form. See, P by Q form. 7 upon 2 means that is 3.5. So number between 3 and 4 is 3.5. And a number line, if you draw number line, here there is 3, here there is 4. So in between here you will get 3.5. But I am not writing in decimal form. I am writing in P by Q form. That is 7 by 2. So 7 by 2 is a rational number lying between 3 and 4. So if you want to find any one rational number lying between two numbers, you want to find the arithmetic mean of these two numbers. You have to take average of these two numbers. 3 plus 4 divided by 2. 3 plus 4 divided by 2. So that is 7 by 2. So this is P by Q form. This is P, this is Q. Q is not equal to 0. P and Q are integer. So 7 by 2 is a rational number lying between 3 and 4. If you want to find any single rational number. Now question arises, sir, if I want to find, you told that there are infinite rational number between these 3 and 4. Yeah, true. There are infinite rational number lying between these two numbers. And if you want to find more than one rational number lying between 3 and 4, so how can we do that? Clear? So this is theory 1. Now, when more than one rational number are determined. If you want to determine more than one rational number lying between two numbers. So what is the theory? How we can find out? So we can say let x and y be two numbers, be two rational numbers. And here you know y is greater than x. And we want to find rational number between x and y, n rational number between x and y. How many n? I am not giving particular number 5, 7, 9, 12, n. We want to find n rational numbers lying between x and y. So you have to find n rational numbers between x and y. So first you have to find d. See, that are what n rational number between x and y. So they are n rational number between x and y are, I can say, see here, first number is x. So that is x plus d. This is one rational number. Then x plus 2d, second rational number. X plus 3d. Okay, x plus 4d. Dot 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 dot. Okay, these all are rational numbers lying between x and y. You want to find n rational numbers, so x plus nd. So these are n rational number lying between x and y, So x and y, and in between these are n rational numbers. Sir, what is d here? Question arises. So where d is y minus x. That is difference of these two given number, y minus x. Y is bigger, x is smaller. So when you subtract a smaller number from bigger number, you get positive upon how many numbers you want. You want to find n rational numbers. So denominator will be n plus 1. If are 5 rational number you have to find, then 5 plus 1. If you want to find 7 rational number, then 7 plus 1. Clear? See, we will do one example so that you can understand properly. Clear? We will do one example. See now, I will give one example. You want to find 4 rational number. Find, just a minute. See, you have to find 6 rational number find 6 rational numbers between 3 and 4. Okay, this is exercise 1.1 textbook question number 2 we are doing. Find 6 rational number between 3 and 4. So here we can say, see here 4 is greater than 3. So let x is equals to 3 and y is equals to 4. Bigger number you have to take y, smaller number you take x. Now we will find d. What we will find? D. Clear? So now we have to find d. So let d is equals to here, d is equals to y minus x. That is difference of two given number upon how many number you want to find? 6. So you have to write here 6 plus 1. That is n plus 1. N rational number between 3 and 4. N plus 1. So that is equals to 4 minus 3 upon 6 rational number. So 6 plus 1. If 7 rational number, 7 plus 1. So 4 minus 3, 1. 6 plus 1, 7. So 1 upon 7. Clear? Now 6 rational numbers between 3 and 4 are, first I told you it is what? X plus d. Theory we have discussed, if you know that 6 rational numbers, here we have discussed. If you want to find n rational numbers between x and y are x and y. Clear? That is x plus d, x plus 2d, x plus 3d, x plus 4d. Clear? Keep on that. So here you want to find 6 rational number. Clear? Between So 6 rational number between 3 and 4 are x plus d, x plus 2, x plus d, then x plus 2d, then x plus 3d, then x plus 4d, then x plus 5d, 6 rational numbers, so x plus 6d. We have discussed the theory, no? So you want to find 6 rational number between 3 and 4 and they are x plus d, 2d, 3d, 4d, 5d, 6d and d we have find out y minus x upon n plus 1. This is the formula, 1 upon 7. Now we will say x. What is x here? So x is 3. So 3 plus d. D is how much? 1 by 7. 3 plus 1 by 7. Clear? Here 3 plus 2d. D is 1 by 7. So 2d is equals to 2 by 7. 2 into d. So 2 into 1 by 7. So that is equals to 2 by 7. Clear? Here 3 plus 3d. So 3 by 7. 3 plus 4d. So 4 by 7. X 3 plus 5d. 5d. So 5 into 1 by 7. So that is 5 by 7. 3 plus 6 by 7. Clear? Now you know how we will solve this. See. LCM 7. 7 3s are 21 plus 1. Have you got it? LCM we are doing here. LCM 7. 7 is LCM. Here 3 by 1. So LCM is 7. 7 into 1, 7. 7 3s are 21 plus 2. Here also 7. 21 plus 3. Here also 7. So 21 plus 4. Here 7. That is 21 plus 5. Here 7. That is 21 plus 6. So numbers are 22 by 7. 23 by 7. 24 by 7, 25 by 7, 21 plus 4, 21 by 21 plus 26 by 7 and 27 by 7. So all these are the 6 rational number lying between 3 and 4. There are not just 6 rational numbers, there are infinite rational numbers between 3 and 4. If you draw a number line 0, 1, 2, here 3, here 4, then between these 3 and 4 all these numbers lies. And there are such infinite rational number. We have just find out only 6 rational number between 3 and 4. Have you got it, friends? So this is the way you can find rational numbers lying between two rational numbers. Clear? Okay, one more problem we will do, see here. Same exercise 1.1 textbook Question number 3. Find 5 rational numbers between 3 by 5 and 4 by 5. So here, which is bigger number? 3 by 5 is bigger or 4 by 5? Denominator is same, see 5 by 5. So we are dividing 3 pizza into 5 parts. Here we are dividing 4 pizza into 5 parts. So naturally this number is bigger. If denominator are same, so can you find out which number is bigger? If numerator is bigger, then that number is bigger. So of 3 by 5 and 4 by 5. If you want to convert them into decimal, you can convert 3 by 5. You divide 3 by 5. So that will be divided by 2, 6 by 10, 0.6. And if you divide 4 by 5, that will be 0.8. So which number is bigger? 4 by 5. But no need of doing so. This has to be done when denominators are different. Here denominator are same. 5, 5. So naturally if numerator is smaller, number is smaller. Here numerator is bigger, number is bigger. So here we can say 4 by 5 is greater than 3 by 5. So let it smaller number x, 3 by 5. And bigger number y is equals to 4 by 5. Clear? And how many? 5 rational numbers. So n is equals to 5. You have to find 5 rational numbers. Now we will find d. D is equals to y minus x. Difference of these two given number upon n plus 1. Clear? This is our difference. We have discussed the theory. If you know that, how you can find d. Okay. See, we have discussed this theory earlier only. When more than one rational numbers are to be determined, let x and y be two rational numbers, y is greater than x. And you want to find n rational numbers. So these are this n rational number. And d is given by y minus x. That is difference of two given number divided by n plus 1. You want to find n rational numbers, so n plus 1. If you want to find 5 rational numbers, then 5 plus 1. Clear? So what is y here? Y is 4 by 5 minus x 3 by 5 upon n plus 1, that is 5 plus 1. So here we will find the LCM. LCM is 5. This numerator, we are talking about numerator, they are fraction. So if you want to subtract the fraction, you have to take NCA. We have learned in lower standard. So LCM is 5. So now 4 minus 3, you will get 1 by 5 upon 5 plus 1, 6. Clear? So that is equals to how much? Numerator 1 by 5. Multiply reciprocal of denominator. You know this is numerator 1 by 5 as it is. When you multiply, you get the reciprocal of denominator. Reciprocal of 6 is 1 by 6. So that is equals to 1 by 30. So D you got 1 by 30. Clear? Now how many you have to find? Now you have to find 5 rational numbers. 5 rational numbers between 3 by 5 and 4 by 5 are, you know what are they? X plus D, X plus 2D, X plus 3D, X plus 4D and X plus 5. These are the 5 rational numbers. 5, so we will go up to 5. Clear? So now X plus D, what is X? X is 3 by 5. So 3 by 5 plus D. D is 1 by 30. D is 1 by 30. X plus D. Now X 3 by 5 plus 2D. 2D. See, D is equals to 1 by 30. So 2D is equals to 2 by 30. Clear or not? It is 2 by 30. So 2 by 30. Here X 3 by 5 plus 3D. 3D. So 3 by 30. Clear? Here X 3 by 5 plus 4D, so 4 by 30. Here X 3 by 5 plus 5D, so 5 by 30. Clear? Now we will find the LCM. So LCM, you know, here you will get 30. 5 is the factor of 30. So LCM of 5 and 30 is 30. You know how to find LCM. 5 and 30, LCM of 5 and 30 you used to find 5 and 30. So you will go by 5, 1s are, and here 6 are, then 6, 1, 1. So 5, 6 are 30, LCM is 30. Or you have to remember, when this two number you want to find LCM, if this 5 is a factor of 30, then bigger number will be the LCM. Here 30. Now 30. So 5, 6 are 30. 5, 6 are 30. 6 into 3. So I can write 18 plus 1. Here also LCM 30. Okay. So 5, 6 are 30. 6 is 18. Always you will get 18. Just here you have to write 2. See. 18 plus 1 upon 30, 18 plus 2 upon 30, here you will get 30, here you will get 18 plus 3 upon 30, same here you will get 30, you will get 18 plus 4 upon 30, same here you will get 30 LCM, so 18 plus 5 upon 30. So these are the numbers. Clear? Now 18 plus 1 upon 30, 18 plus 1 means 19 upon 30, 18 plus 2, 20 upon 30, 18 plus 3, 21 upon 30. 18 plus 4, 22 upon 30, 23 upon 30. Now we have to write in reduced form, equivalent rational number. 19 upon 30 you cannot divide, so 19 upon 30, 20 upon 30, 2 to cancel, so 2 by 3, 7, 7, 3 we can say, 3 7s are, 3 10s are, so 7 upon 10. Here 2 11s are, 2 15s are, so 11 upon 15, 23 upon 30. So these are the 5 rational numbers lying between 3 by 5 and 4 by 5. Have you got it, friends? In this way you have to find the rational numbers lying between two numbers. Clear? So I hope you understood this. Same thing, we will do one more problem. See, very easy problem. See now, same exercise 1.1, question number 2. Question number 2. What is that? Find 6 rational number. Find 6 rational number. Sorry, we have done this. Okay, I'm sorry, extremely we have found this 1.1. We have this completed. So now we have question number 1. Exercise 1.1, question number 1. Is 0 a rational number? Is 0 a rational number? Can you write it in the form P by Q, where P and Q belongs to integer and Q is not equal to 0? This is our question. Is 0 a rational? So I have explained you, yes, 0 is a rational number. You know that, yes, 0 is a rational number. Because you know that, because we can write 0. See, we can write 0 in the form P by Q. 0 is equals to 0 by 1. Okay, where 0 and 1, see, where P and Q. So where P and Q should be integer. So when 0 and 1 belongs to integer and denominator 1 is not equal to 0 and Q that is equals to 1 is not equal to 0. So 0 is a rational number. 0 is an integer and all integer are rational number. Clear? So 0 is also integer. I told you, see, all integer dot 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 minus 3, minus 2, minus 1, 0, 1, 2, 3, all these are integer and they are rational number. Why? Because they can be written in the form P by Q, like upon 1, upon 1, upon 1, upon 1, upon 1, upon 1. So all integer can be written in the form P by Q. So 0 is an integer, so 0 by 1. It is also a rational number. Clear? Now we'll discuss exercise 1.1, question number 4. See what it says. Every natural number is a whole number. Every natural number is a whole number. Yes, every natural numbers are whole number. Why? Because natural number, you know, say natural number n is equals to 1, 2, 3, 4, 4, 5, these all are natural numbers and they belongs to the whole number. So every natural number is a whole number. So this statement is true. It is true. Every natural number is a whole number. This is true statement. Now second statement is given here. Every integer is a whole number. Every integer is a whole number. See, you might be knowing integer z is equals to what? Dot 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 minus 3, minus 2, minus 1, 0, 1, 2, 3 dot dot dot. These are integers. And whole number you know that is 0, 1, 2, 3 dot dot dot. So all whole numbers are integers. But all integers are not a whole number. Here every integer is a whole number. So that statement is false. Reason what you can say, see, these negative numbers are not included in whole numbers. So reason we can say, the negative integers are not whole number because negative integers are not whole number. Clear? So third one now. What is given third one? Every rational number is a whole number. Every rational number is a whole number. Every whole number is a rational number. But every rational number is a whole number? No, this statement is false. Every rational number, see 3 by 2, this is a rational number, it can be written in the P by Q. But 3 by 2 is a rational. 3 by 2 is a rational, but not a whole number. So therefore we can say every rational number is not a whole number, but every whole number is a rational number. So with this we have completed your exercise 1.1. I hope you have enjoyed this lecture. So I have explained you what are natural number, what are whole number, what are integers, what are rational numbers, equivalent rational numbers, and method to determine rational number between two numbers. That is, if you want to find one rational number between two rational numbers, or if you want to find more than one rational number between two rational numbers. Clear? So with this I am going to complete today's lecture. We have discussed rational number. In next lecture we will discuss what are irrational numbers. Clear? So till then, thank you very much.